Welcome back to the Python Praxis. Today we're diving deeper into the world of lists with Lesson 9, Advanced Topics in Lists. So far, you've learned the basics of lists, what they are, how to index and slice them, and how to modify them. But lists in Python can do much more. In this first part of Lesson 9, we'll unlock some of those advanced skills. How to convert between different sequence types. How to copy lists properly and understand shallow versus deep copies. How to use list comprehensions to build lists quickly and elegantly. By the end, you'll not only know how to write less code, but also how to handle lists like a pro. So, grab your keyboard and let's get started. First, let's talk about converting between different sequence types in Python. Python gives us constructors like list and tuple functions that allow easy conversions. A first case is from tuple to list. We can create a list from a tuple using the list function, which is also called list constructor. The original tuple, of course, remains intact. For example, we start with a tuple named tuple1 that contains 5 integers, 2, 4, 6, 8, and 10. Using the list constructor with argument tuple1, Python creates a list called list1. Another case is from range to list. Using the list constructor, we can create a list from a range of numbers. In the example, putting range 20 as the argument in the list function, Python creates a list of numbers from 0 to 19. A third case is from string to list. Again, using the list constructor, we can create a list containing the characters of a string. In the example, we set the string as the argument in the list constructor, and Python creates a list with all the characters of the string. We also have a reverse case to go from list to tuple. Here we can create a tuple from a list using the tuple function, which is also called tuple constructor. The initial list, of course, remains as it is. In our example, we have a list named list2 that contains 5 integers, 3, 5, 7, 9, and 11. By putting the list as an argument to tuple constructor, Python creates a tuple from the list. This flexibility makes Python great at moving between data representations. Now, let's talk about copying. In Python, assigning one list to another, like in the example, does not create a new list, it just creates a reference. So changes to list2 will affect list1 and vice versa. So how do we make proper copies? Here we have 3 methods to do the job. One method is using slicing. This is the most common and fastest way. Let's say we have a list called original, with elements 3 integers, 10, 20, and 30. Assigning to copy 1 the original list sliced, putting only a colon inside the square brackets, creates a fresh copy. Then, changing an element in copy 1 list will not affect the elements in the original list. A second method is using the list constructor. This way also creates a new list. A third option is to use the copy method. So by assigning to copy 3 the original list.copy, also creates a new independent list. All the above methods, though, create a shallow copy of a list. This means that these methods work fine for lists with simple values like integers, strings, floats, or booleans. In the next slide, we will see cases of shallow copy pitfall. In case a list contained other lists, which means we have nested lists, all 3 methods we explained in the previous slide will not work correctly. Let's see an example to understand why. We define a list named original with 2 elements, where both these elements are lists themselves. The first element is list containing integers 1 and 2. The second element is another list containing elements 3 and 4. We will use the slicing method to create a copy of the original list, and we name this new list as copy1. Now, we change the first element of the first inner list in the copy1 to 99. We notice, though, that this change has also affected the original list. This happens because both original and copy1 lists point to the same inner lists. To overcome this issue, and make a full copy of a list that contains other nested lists, we must use the copy module. For this, we must first import the copy module. Then we use the function copy.deepCopy with argument the original list. This way, we have 2 completely discrete lists, and any changes in one list will not affect the contents of the other. So remember, use shallow copies for simple lists. Use deep copy for nested ones. Comparing now all copy methods in this table, we can say, using slicing works for all types of lists, but it does not do deep copy, only shallow copy. Using the list constructor also works for all types of lists, but makes only shallow copy. Using the copy method from Python version 3.3 or later works for all types of lists, but again, here makes a shallow copy. Only using the copy module with the deep copy method, we can have a full deep copy of a list, and we use it if we have nested lists. Now comes one of Python's most refined features, list comprehensions. A list comprehension is a concise and elegant way to create a new list by performing an operation or filtering elements from an existing iterable, like a list, a range, or a string in a single line of code. The syntax is, we start the line with an expression followed by the keyword for. Then comes the item, a variable name followed by the keyword in, and last is the name of the iterable. All in one line. The expression is the value to include in the list. The item is the variable name representing each element of the iterable. The iterable is something you can loop over, such as a list, a string, a range. In our example, we have a list named numbers containing 4 integers, 1, 2, 3, and 4. Then in a single line we have squares equals, and inside square brackets we put x in the power of 2, 4, x in numbers. The output will be a new list named squares, containing the squares of each number in the numbers list. Just to compare, below is the classic way to do the same job. But here we need 3 lines instead of 1. In the first line, we create an empty list called squares. In the second line, we start a for loop, and in the third line, we calculate and append the square values to the new list. We can also have a list comprehension with an if conditional. The syntax adding an if conditional for inline decision is, we start the line with an expression followed by the keyword for, then comes the item, a variable name followed by the keyword in. After that is the name of the iterable, followed by the keyword if and a condition. All these in one line. The expression is the value to include in the list. The item is the variable name representing each element of the iterable. The iterable is something you can loop over, such as a list, a string, a range. This means that the expression will be calculated and the value will be added to the list for all items in the iterable that fulfill the condition. For example, we can write list1 equals, and in square brackets we put n in the power of 2 for n in range 20 if n modulo 3 is equal to 0. The output will be a list named list1, containing the squares of the numbers in the range from 0 to 20 that are also multiples of 3. Below is the code of the classic way to do the same job. But here, we need 4 lines instead of 1. In the first line, we create an empty list called list1. In the second line, we start a for loop. In the third line, we add the if condition. And in the fourth line, we calculate and append the square values to the list. We can even have a list comprehension with an if-else conditional. The syntax adding an if-else conditional for inline decision is, we start the line with the expression if the condition is true, followed by the keyword if and the condition. Then comes the keyword else, followed by the expression if the condition is false. And after that comes the keyword for and the item, a variable name followed by the keyword in and the iterable. All of them in one line. The expressions are the values to include in the list if the condition is true or false, respectively. The item is the variable name representing each element of the iterable. The iterable is something you can loop over, such as a list, a string, or a range. This means that if the condition is true, the expression if true will be calculated and its value will be added to the list. Otherwise, if the condition is false, the expression if false will be calculated and its value will be added to the list. In this example, we have labels equals 2, and inside square brackets we put even if x modulo 2 is equal to 0, else odd for x in range 0 to 5. You can see also the code of the classic way to do the same thing. But here we need 6 lines instead of 1. In the first line, we create an empty list called labels. In the second line, we start a for loop. In the third line, we add the if condition. In the fourth line, we append the expression if true. In the fifth line, we have keyword else. And in the sixth line, we append the expression if false. Now a real-world style task with user input. A tuple creation exercise with filter and process of even numbers. We will create a Python program that reads 8 integers between 5 and 15 from the user, stores the numbers in a list, converts that list into a tuple, creates a second tuple that contains the cubes of the even numbers only, sorted in descending order. Let's examine the code lines now. We start by defining an empty list called values. Then we create a while loop to gather the 8 integers from the user. Within this loop, we have an if conditional that checks whether the number given by the user is in the valid range. If yes, it appends the number into the list, otherwise messages the user to try again. The next line after the loop converts the list to a tuple using the tuple constructor. In the next line, we create a list named even cubes, containing the cubes of only the even numbers from values list. Then using the tuple constructor, we create a tuple with the elements of even cubes list sorted in descending order. The last two lines print the original tuple and the sorted cubes tuple. And that wraps up the first part of Lesson 9. We've seen how to seamlessly move between tuples, strings, and lists, how to copy lists the safe way, and how list comprehensions can turn bulky loops into a single elegant line of Python. Take a moment to practice these tools. The more you use them, the more natural they'll become. But don't stop here, because in the next video, we'll step into the world of two-dimensional and multi-dimensional lists. Think of tables, grids, and even matrices. See you there, and let's keep sharpening your Python skills together.